We're going to go over some key problems for the second assignment. First thing I want to tell you is make sure that you have a Desmos open, and also make sure that you have a standard normal probabilities form open, standard normal probabilities. You might need both, you might need one. It's very important that you have these open. So first thing is just getting us ready for like, what are we talking about, right? Are we talking about below, above, in between? And all you do is type in the Desmos this domain, right? Negative infinity to 0.4. And then you write the answer down. So if you go into Desmos, you're going to do this, right, by going into the keyboard, the function, the distribution, the normal distribution, and then click CDF. Sometimes you have to click that twice. And so negative infinity to 0.4, and I literally just write this number down. 3 or 4 decimal places, that's all you have to do. So this one, we would just write down 0.6554. That's it. It just wants the, notice what it wants is it's looking for simply the probability. Probability is a decimal as opposed to a percentage, which is 65.45%. And then here we go through the algorithm of, well, what do I do if I say left or right? Keep in mind, left means negative infinity, right means positive infinity. Literally, it just means put the infinity on the right as opposed to the left. So to do those problems, you're literally just going into Desmos. Left would mean negative infinity to 1.54. You write that down. The next one, it wants right. So you put the infinity here, and you can just type infinity in the Desmos. It's beautiful. And then I put 1.28 here because I want the infinity on the right side. If you make a typo, just change it. So I write that down. If I go between, I would just type in 0 here, and then here I would type in 1.96. So let's talk about the chart. Well, if I had this first problem, left would be negative infinity, okay, to 1.54. What I would do on the standard normal probability chart is I would get the chart out, and I would look for this value. I want to look for 1.54. So I don't look at the negative side. I go to the positive side, 1.54. Notice it's showing you left. It's literally saying this is a left type of chart. So I go to 1.54, 1.5, go to 4, which is right here, and I get 0.9382, which is exactly the same thing as I get in Desmos, 0.9382. Okay, if I go back to this one and I want to do to the right, well, keep in mind the chart is a left chart. So that means do the opposite of what the chart says. So instead of looking at 1.28 to get this number, 0.10027.256, I go to the chart and I look up, I wanted positive, right? I want positive 1.28. The chart is a left chart, so I do the opposite. I look up negative 1.28. So negative 1.28 right there. There it is. It rounds at the 4 decimal places, so you can see that 0.1003 is the same as, if I put this in here, 1.28 to infinity. All right, so how do I do the chart for, see, it's the same thing. How do I do the chart if I want to do this? Well, I look this up on the chart, which 0 means it's 0.500. I look this up on the chart, which is 0.975, and then I subtract them, and then I would get what Desmos gave me. All right, so that's how you would do that. Speaking of the chart, what if I want to turn a percentile into a z-score, which is very necessary to complete real-world problems? Well, I have to understand that percentages don't show up on charts or Desmos, so I change the 70 divided by 100 and get 0.7. Then, if I use the chart, it's actually a little easier in my opinion. I go to the chart and I look for 0.7. Don't see it, don't see it, don't see it. Okay, it's in here. And so you can see it's in between these two. Well, you would always round down because you don't have these other decimal points. Like I don't have the decimal point for 2.1, 2.2, 2.3, 2.4. So you round to this number, you round down, and then you go this way. It's 0.5 and 2, 0.52. Okay, and so that would be the z-score. Or you go into Desmos and you type in function inverse CDF, and inside of the inverse CDF, you put the normal distribution. Now, there's a little bit of a weirdness here. You have to tell Desmos that you like the mean to be 0 and your standard deviations to be integers of 1, 2, 3, 4, or -1, -2, -2, -3, -4. And I will show you something that's really interesting. If you try to come in here and finish this, do you see how that X has come in to become highlighted? It's going to get rid of the whole thing. Very annoying. So what you do is you have to move this to be bigger. You might have to move the window this way. And you want to be able to see space in here. Then do it, and it'll be easy. Inverse CDF, normal distribution, 0, 1. Click here and put in 0.7. But Desmos thinks that that means you want to multiply. It even says multiply. It wants you to put a comma here, so it means you're not trying to multiply. And then you get the same thing I got on the chart, 0.52. Okay, and then the last part that we did on the front, here is to do an actual z-score problem. So you take the x value of 35,150 miles, you subtract the mean of 30,000 miles, divide by 2,500. The first question is, what is the z-score? The next problem is directly connected to this. It basically says take the z-score and convert it to a percentile, and that means left probability. Keep in mind that if somebody's asking you for a percentile means a graph like this, and you're shading here. Like that's the definition of what percentile means. So that's just a straight up look up the z-score on the chart, or to use Desmos for that, you would just come in here and you again would do normal distribution, CDF. See, I had to click it twice that time. Negative infinity to the z-score of 2.06. So that comes out to the percentile. Now, percentiles are always rounded down. So if you have 0.9803 or 0.9899, those are in the 98th percentile. This is what's known as the greatest integer function, or the round down function. Keep in mind that if you have 0.9899, you are not in the 99th percentile. You're in the 98th percentile, meaning anything between 0.98 and 0.9899 is considered to be in the 98th percentile. All right, so on the back of this paper, we just have some applications of that. So again, so here we're finding the z-score, 10 minus 45 divided by 15. I got those values from here, right? 45 is the mean, and then the standard deviation is 15, okay? And then this value right here is x, and then I got 2.3, and then immediately connected to that is a. Please convert that to, okay, we're not converting this one, we're actually using it to explain how many shoppers there would be. And this is like going back to middle school math, where I would say something like, what's 35% of 100, which is easy, that's 35. So what's 35% of 15? And the way you would do that problem in middle school, is 35% is really 0.35 times 15, right? So that's actually 5.25. That's exactly what's happening here. I take the 0.0098, and then I multiply it times 200 shoppers, and it tells me that I'm getting like 1.96 people. So I said between 1 and 2 people, because like what is 0.96 of a person? That doesn't make sense. And so even if you had like a between one where you had something like this, again, the confusing thing about this is you have to do it twice. So you have to do 5, right, minus 45, and then you take that and divide it by 15, and you get the first z-score. And then you take 15, and you subtract 45 from that, and then divide by 15, and you get a second z-score. And that's going back to this concept, right? That's talking about something like this, where it was between, or between, like this. And so you would type that into Desmos by going into Desmos, going back to the CDF, and putting in those values, negative 2.667. And then here we would have negative 2, and that is the probability or area. And then to figure out the number of people, you would just take that. Again, if you want to, you can just copy it, right? You just copy it and say, hey, I would like to multiply that times 200 people, so about 3.78, or between 3 and 4 people, or 3 people. All right, and then the rest of it's kind of like that, other than maybe this problem right here where you have to use a z-score to then figure out your ACT score. Keep in mind that this right here is not this. They're not the same thing. So if you put 0.6 into this equation, it's wrong. You have to convert it by using the chart. So let's find 0.6. It's right here. And so it's actually round down to this. So 0.25. Again, 0.2 this way, 0.05 that way, so 0.25. So you have to convert that, or you can convert it on Desmos. Just remember that you have to do 2 things: inverse, the normal, 0, 1. Here you have to put a comma and then 0.6. Notice I get the same thing, 0.25. and then I go back into here and just make sure that I don't put 0.6 in there. I have to put in there, I have to put 0.25. Okay, and then I just solve this algebra problem. I put the mean, right? So in the problem, the mean is 24, so I put 24 here, and the standard deviation is 4.3, so I put that here. And then I solve this for x. Your first step is to multiply by 4.3, and then you keep going, you'll find x. Down here, we're trying to find like where in the world does the mean and standard deviation even come from. I will tell you the SOL has gotten rid of the mean absolute deviation, so you may get rid of that on every problem. But let me show you how to type this in. You go into Desmos and you add a table. So what I'm about to do is I'm about to add a table, okay? Okay, so I added that table, and then you want to make sure that you double check it. The worst thing you can do here is make a typo and then get frustrated and then have to type the whole thing in again because you got an answer wrong. So 10, 8, 10, 10, 10, 11, 10, 12, 12, 12, 9, 13, 7, 8, 8, 11, 9, 10. Then you go all the way to the bottom of the table, and here you insert what you're looking for. You're looking for statistics. So you go to the keyboard, go to Functions, Statistics. You want to find the mean. Now keep in mind, mean of what? That's what that's saying. Like, what are you asking for? Well, we type this into x1. So just hit an x and a 1. The 1 will automatically go in as a subscript and tell you the answer is 10. The mean is 10. What is the standard deviation? Go to Function, Stat, Standard Deviation, x1, 1.645. And then here, go to the variance of x1, and that's 2.706. That's what I wrote down here. Now, what is the variance? Because we've obviously talked about mean and standard deviation. The variance is a measure of whether or not your curve is normal. The lower the variance is compared to the mean and standard deviation, the better it is. So this one's pretty good. It's a very small number when comparing to mean and standard deviation. If this number is like 27 instead of 2.7, that would mean my data is not normal. I basically need to collect more, or my information is not coming out to a normal range. Well, I hope this helped, and I hope you're able to finish your homework.